is the prime factors kata. This is a kata that has us using test-driven development to create a function that accepts a single integer parameter and returns a list of its prime factors. So use Alt-Shift-N, J, create a new Java project called prime factors, and then take the defaults, Alt-Shift-N, hit J a few times, get down to J at test case, call this prime factors test, hit Shift tab a few times, put in the prime factors package. Let's write our first tests. Use the template for JUnit4 test, call this 1. Let's assert equals that we get a non-existent function that returns an empty list when we prime factors dot generate prime factors for 1. Okay, let's use control less than to go over to list, hit control 1 to create method list, and tab down to list integer. That's what it should return a list of integers. And then let's delete this line, and instead of having it return null, let's have it return a new array list of integers, not integers. Okay, use Control Shift O to import java.util.list, and array list comes along with. Let's create class prime factors. Okay, defaults are fine. Create method generate within prime factors. Have it return a list of integers, and then our parameter should be n. Let's delete this line, and returning null is fine. Let's import java.util.list first. Let's go back. Well, actually, let's split the screen. Okay, Control M to maximize. Let's go back. Actually, let's move our list helper method to the top, holding Alt after selecting. All right, let's run our tests, and they fail. Well, the reason is because we're automatically returning null in our generate method. So let's return a new array list of integers. Okay, let's run our tests. Alt-Shift-X, T, and they pass. Okay, let's write another test. Call this one 2. Let's assert equals the wake list containing the number 2 when we prime factors dot generate prime factors for 2. List does not accept parameters, so let's have it do so. So integer dot dot dot. Let's call this the parameter ints, and then in the constructor of new array list integer, let's pass in arrays dot as list ints. Okay, well, let's run the test. Alt-Shift-X, T, they fail, expected 2 but was empty list. So let's go to our production code, and let's create a local variable of this. Call it primes, and just for clarity's sake, let's have it be a list instead of an array list as declared. Okay, so let's say if n is greater than 1, we want to primes.add 2. Let's add 2 to our list. That'll make the test pass. So Control 6, Alt-Shift-X, T, save off the file, and it passes. So let's write another test. Well, actually, first, let's do this. Let's do Control-Shift-M and statically import our generate, so we don't have to keep typing that. Alright, so now let's write another test. Oops. Let's call this one 3. So let's assert equals, we get a list containing 3. When we generate prime factors for 3. Let's run the test. And it fails. That's because we're returning the magic number 2 instead of n. So let's go back, run our tests, and they pass. So, okay, let's write another test. Let's call this one predictably 4. Let's assert equals that we get a list containing the numbers 2 and 2 when we generate the prime factors for 4. Alright, let's run the test. And our 4 doesn't pass. So let's go ahead and inside our if, let's write another if saying if n mod 2 equals 0. If it's evenly divisible by 2, what we want to do here is primes dot add 2, and then let's factor 2 out of our n and divide equal 2. And then down here what we'll want to do is we'll want to surround this by an n greater than 1 again. So let's use Alt-Shift-Z 3, surround it with the condition n greater than 1. Alright, Alt-Shift-X-T when we're focused on our tests and they pass. So let's write another test. We don't need to do 5 because we've already taken care of the prime case. So let's move on to 6. Assert equals that we get a list containing the numbers 2 followed by 3. When we generate prime factors for 6, run the test, and they pass. That was easy. So let's write another test. Call this one 8. Assert equals, well, 7 is unimportant. We get a list containing 2 followed by 2 followed by 2. When we generate the prime factors for 8. So let's run the tests, and 8 fails. So let's go ahead and fix it. What we're doing here is we're only checking for divisibility by 2 once. So let's change this if to a while. Go back and run our tests, and they pass. So let's write another test. Call this one 9. Let's assert equals that we get a list of 3 followed by 3. When we generate the prime factors for 9, so we run the tests, and they fail. So let's see, let's make this pass. Well, we don't want to always check for 2 for divisibility, so let's factor that out as a local variable and call it candidate. That's using Alt-Shift-L. Let's replace all occurrences, make sure that's checked. Let's increase the scope of the declaration of candidate. Well, we want to keep doing this, so let's change this outside if to a while. We want to be sure to increment candidate after the inside while. And, well, this if n greater than 1, that's kind of what we were doing at the very end of our process, so let's go ahead and move that outside. So let's go back to our tests, run them, and it passes. So let's do a little cleanup. So let's transform this while into a for loop. There's no initializer, so let's not have that. The condition remains n mod candidate equals 0. Our incrementer is actually not an increment. It doesn't increment, it just checks for, not equal candidate. And then we can delete these curly braces because there's only a single line in our for loop. So let's go back and run the test. And they pass. We haven't broken anything yet. So let's go back and refactor a little bit more. So this while loop can be written as a for. So let's 4, and then our initial condition is candidate equals 2. Our condition is that. Our incrementer actually increments this time. So let's go ahead and use that. And then we can delete that semicolon, but we can delete the curly braces because the only line in our outer for loop is the inner for loop. So let's go ahead and run the tests, and they pass. So let's go ahead and, well, as we can see, the condition on our if statement is identical to the condition on the outer for loop. So we can go ahead and delete, because that'll never get hit. So let's go back and run the tests, and they pass. So that completes, well, not exactly. The final step of our kata is to delete the prime factors and contents on disk. And there you have it. That's the prime factors kata.